So day 2 a little here with focus and directrix. Going to do a little bit of review with some things. Again, if you need a little bit of assistance with anything, remember your handy dandy formula sheet that we got out to you yesterday, so we can kind of work a little bit on getting used to the different formats that we can use. In this first section, it says write an equation for each parabola described below, then graph. Now, there's some different pieces that they give us in each of the questions. Notice on the first 3 they give us the focus, the 4th one they give us the directrix. So let's do one of the focus ones, and shoot, let's do one of the nasty ones. Let's do number 3 here. So if we look at this, we're like, okay, I know that my vertex is my HK, and I also know when I'm doing my focus, if I think back to yesterday, because it won't be at the origin, my focus is HK plus 1 over 4a. So how does that help me figure out the information I need to graph this equation? Because since my vertex isn't at 0, 0, like it is on number 1, in this case, the equation that I'm going to be working with in general is this y equals a x minus h squared plus k. Same thing you've got on your formula sheet. That's just my general vertex form of a parabola. So I look and I'm like, okay, well, what information do I have and what information do I need? So I start to look and I'm like, well, I don't know a yet, but I think I'm going to be able to figure that out in a minute. I already know what h and k are. So I can go ahead and I can plug those parts in. The question's going to be, what's this a value? So I come back and I look and I say, okay, well, the focus is k plus 1 over 4a. Okay, so if that's the case, my k is negative 4. So negative 4 plus 1 over 4a is going to equal this second value, or my y value of my focus. Negative 3 7/8. Ew. That doesn't look like a lot of fun. Now, here's where I look at things a little bit differently than some of you may. Some of you may look at that and off the top of your head say, oh, this isn't a problem. And I would kind of hope this would be the case. You'd look and you'd say, okay, if I'm trying to solve for a, I'm going to add the 4 to the other side. When I add that 4, I've got 1 over 4a. 4 minus 3 7/8 gives me 1/8. And now to solve it, I'm like, oh, 4a equals 8. So a equals 2. And once I have my a, I pop that here, oh, bless you, pop that into the front, and I can be set. And some of you may look at this and say, well, do I really have to have x minus 0? Wouldn't that just be x squared? So I'd just write it like this, to which I would say, yeah, that's probably a better way to go, but either one's going to be fine. So basically what you're doing with any of these is you're going to have to do a little bit of algebra typically to find your a value is the only thing you're going to need. Everything else you're going to have with this. So let's just say you're doing that just below with the one that's got the directrix. So you're like, okay, vertex again. I know I got h and k. So I'm not going to have a yet, but it's x minus h, so that becomes plus, okay, plus 1. So the directrix, now how's that work again? My directrix is y equals k minus 1 over 4a. Okay, so if that's the case, hk, my k value is 1. So 1 minus 1 over 4a equals 2, because they're both y equals. So these two are equivalent. I'm like, okay, solve it like an equation. The key is just going to be getting used to these two little mini formulas for your focus and your directrix. Once you've got those into your head, and there's not much difference, you notice, it's like k plus 1 over 4a and k minus, so it's not like they're completely different. And then again, I'm just going to calculate and figure out what my a value is going to be. So here, you could either multiply both sides by 4a if you wanted to, I suppose, and then divide by 4. And I get my a value to put in front of my expression. And then again, as far as the graphing goes, I already know what my vertex is. So for most of you, I'd assume we're just going to plug this into the calculator, and I'd use the table function. I like keeping life simple when it comes to those, especially when you've got access to the calculator. The nice thing about doing it this way is going to be, let me mention that too. If you do decide you're going to use the calculator to help you graph, so if I come back to 3 for just a second, you're actually going to get to affirm the fact that you did it right. So like if I type in my first one, I'll just look at the graph so I see, oh, it's looking okay. And then I go to second table, and I'm like, okay, if I've done this correctly, my vertex should be 0, -4. Okay, there it is. And I see the symmetry that's happening around it. Now, if I made a mistake somewhere and my equation's wrong, when I go to graph it, my vertex won't be my point that's in the middle. But in this case, it is. So I'm going to go ahead, plot my vertex, and then I'm just going to look for some values to the left and to the right that are going to get me that nice even U shape to open that up. So that's the nice thing about finding all of your information in your equation first, then graphing it. Because then it's just that little bit of aha in making sure that, okay, you know, I did this right. And I'll even do that down here on 4, just again, to kind of reinforce some things. So I've got -1/4. And I would need to put that in the parentheses if you have a calculator that doesn't have like a fractional button on the side, because otherwise it's going to become something completely different from what we're trying to get. All right, with this much stuff, I better double check, make sure I typed everything in right. And I did. So hopefully, when I get to my center at -2, 1, I see symmetry, and I do. The 0.75s, as I go 2 values out, at 0, and so on. So I can get so -3 and -1 are at 0.75, and -4 and 0 are at 0. But again, my key there is it's more of a double check for me with the graph than it is anything else. So as you're doing any of these, and the one other thing I wanted to mention on this sheet, which I'll probably mention more on the couple of questions we look at on the quiz preview, is when it talks about, okay, we can identify the vertex, that's not a big deal. The axis of symmetry, okay, it's the x value of my vertex. I got that. The direction of opening the parabola. Now remember, there's two things that helps me with. If I notice that it's opening down, remember, that's going to have a maximum value because the point where it changes is at the very top of my graph. If it opens upward, I'm going to have a minimum because that turning point's at the very bottom of my graph. So you may be asked a question here or there, is there a maximum or a minimum? Which direction is it opening? And again, that all depends on our a value. If our a value is negative, these two things occur. If my a value is positive, these two things occur. So all of these things tend to have a relationship with each other. But a lot of it's just going to be, okay, I got to use my formula from the sheet here. Okay, how's this going to work? Oh, yeah. And kind of play with it a bit. And I don't think there's going to be anything else. I'm trying to peek. It's going to be too terribly awful on here. Take a peek through the rest of this, even if you want to on the back. Is there something else besides the immediate fact that story problems can be scary? Is there anything else on there that you immediately want to kind of go through and say, wait a minute, what is this actually asking for? Because I want to make sure we've got you on a good set with this after yesterday. Anything else that looks problematic yet? Because otherwise I want to talk a little bit about the quiz preview too, even though our main focus with that's going to be on Monday. Otherwise I'll get out of the way. For the time being then, just for a moment here, I'm going to hop over to the quiz preview. I just want to do one of these up at the top, just to kind of reinforce what we just said on the other sheet. Sketch the graph of the function. State the vertex, domain, range, and if it has a max or a min. Holy cow. So at the start, these all are in vertex form, which is nice. I don't have to use the formula to figure out what the vertex is going to be. What would my vertex be for number 1? -2, -1. Okay, so -2, -1. So let's see. Domain and range, we probably should see what the graph looks like first, and whether the graph has a max or a min. Okay, probably easier with all of these things, at least the first couple, if I actually graph this first. Now again, if you're comfortable, and I know a lot of you would be, you know the vertex is at the center of your graph. You know you want a couple of values that are less than and a couple of values that are greater than. If you're comfortable just mentally plugging the numbers in, popping your y values out and graphing it, hey, I say go for it. But if you're in a little bit of a mode and it's like, yeah, you know, it's Friday, it's homecoming day, maybe, just maybe, I want to do this a little bit differently, like let the calculator help me. That's okay. So all I would do is I'd type it into the calculator. Make sure I've done everything accurately here. Yep. And then when I go to graph, I should notice again, okay, there's my vertex, and I see the symmetry. And once I see that, I'm like, yep, I did this right. I'll just jot these values down. I'll plot the points that go along with. And now I've got a picture at least to work with. Bless you. So I can answer some of the other questions like, does it have a max or a min? Well, when it opens down, that's always going to be a maximum. We already did the vertex. Now domain and range we haven't talked about as much lately. Okay, domain again is my x values going from left to right. Well, when I see those two arrows, which means this will keep expanding outward and downward, and this will keep expanding outward and downward, it lets me know that basically when I'm working with a parabola, my domain's going to be all reals, -infinity to infinity. The thing that'll have the change is going to be your range. Like for instance here, where's the bottom value of my range going to be at? -infinity. And then wherever that top point is where it'll end. So it'll look like this when you're opening down with a parabola, but if you're opening up, the infinity would be at the end and be positive because there wouldn't be an upper limit to my range. And then again, it's just some practice with getting your vertex, getting your focus, getting your directrix, and kind of just playing with them some more so you can get the hang of things. So any other ones, any other questions? Because otherwise I'll give you the last half here to do your own thing, and if you've got questions you can see me, and if you want to check a key you can, and we'll get you ready to go here. Alrighty.